is from a math competition for ninth grader in Russia. Now it is about quadratic root difference. The difference is going to be the bigger value of the root minus the smaller value. So it's always a positive number. Here we're given that f and g are monic quadratic. Remember, monic meaning the leading coefficient is 1. That is, the typical expression for quadratic is ax squared plus bx plus c. Here a equal to 1. Now f and g are monic, and both have the same root difference of some positive number t, and f plus g, which is the summation of the two polynomials, also has two distinct real roots, but the root difference is s. We need to prove that s is going to be less or equal to, that is, no greater than t. Right? There's a lot of information to digest. Pause the video as always because you want to solve the problem yourself before viewing the answer. Now let's review that the roots of quadratic given this coefficient ABC, of course a is non-zero, that's two roots. Here the determinant here is going to be positive because we know we're given that they have two real numbers, right? So we know the sum and the product. But here we're interested in the difference, right? The difference here, this would cancel. This is plus and minus. So you're going to 2 of determinant square root over 2a, and 2 would cancel. So that would be the difference formula. So in our case, we're talking about monic polynomial. That is, a is equal to 1. So the root is going to be here a equal to 1, and the root difference is going to be this. Alright, that's some background we reviewed. Now let's go back to the problem. We're given f and g have the same root difference t, and we'll try to prove s is smaller or equal to t. Alright, let's plug in the formula here, right? G has coefficient d and e, and we plug in the formula here because they have the same root difference t. That's the equation we have. Now, when we add up the two polynomials, we just add the coefficient here. Notice that the leading coefficient is no longer 1, it's 2 now. So we plug in the formula for the root difference. That's for f plus g. We need to prove s is no greater than t. Let's review what we have. Let's expand this. Alright, so we're going to have this. Now here, you notice that you have b squared minus 4c and b squared minus 8c. Now, what if we have a factor of 2 here? This term is extra term. Here we're going to use a very famous inequality derived from AMGM inequality. That is 2bd is going to be smaller or equal to b squared plus d squared. We notice that 2bd is going to be less or equal to b squared plus d squared. Right? This is true for all real number. Equality holds when b equal to d. Now we're going to replace this with b squared plus d squared, and that would be give us twice of b squared and d squared. Alright, let's do. So that's what we have. Alright, let's recap. This is what we have. Notice that b squared minus 4c here is going to be equal to t squared, right? So let's rewrite this equation here to t squared, and here you're going to plug in 2t squared and plus 2t squared plus 2t squared. That's going to be 4t squared, right? And square root of 4t squared is 2t, over 2 is that t. So we have proven using the basic inequality that s is going to be less or equal to t. That's the proof. This problem is interesting. I think it has easy to medium level of difficulty. Hope you follow the steps and enjoy the video. Please like, share, and subscribe to the channel.